and 5, 4, 3, 2, and 1. And we are the Little Shop of Physics, and we are live on Zoom and also on Facebook. And we have a program for you today about rocks. And teachers have asked for us to do something about earth science. We wanted to do a show on rocks for a long time, but I don't have any particular expertise in rocks, but fortunately we have a compatriot who does. So we're going to zoom in quick to Denny Hireman down in Loveland, retired high school science teacher. And Denny is also a geologist and was a radio announcer and a butcher and has had more careers than anybody I know. And Denny knows all kinds of amazing things about rocks. And so special shout out to Denny for all his help. And all the special samples we're seeing today came from Denny's basement, which is kind of an amazing, amazing place. So Denny, thank you so much.
Thank you, Denny.
Without further ado, I'm going to show you the first sample from Denny's basement, which is right here. And these are super, super special rocks. And what we're going to do, we're going to show you some rocks that tell stories and also rocks that you can find and talk to you about how you might look at them. And these are some rocks right here. And I have found these before, rocks like this, in my yard. And it turns out, if we do a close-up view of these rocks, we've got a little picture of the rocks that we can show close up and see what they look like. And check this out. They look like little spheres. They are little spheres. And these were little melted bits of iron that fell from space. These are micrometeorites. And you can find these near your downspouts. They land on your roof, and the rain washes them down your downspouts. And if you take a Magnetite, you can collect these. And if you separate out the little magnetic bits, you will have some of these little round pieces. They're little space rocks, and you can find them in your yard, which is kind of an amazing, amazing thing. Now, we took a closer look here, and that's the theme of our first piece. Sometimes you look at a rock, and it's like, oh, it's just a rock. But if you take a closer look, there's a little bit more that's revealed. And Maud has our first piece that we're going to take a closer look at.
Yep, so I've just got this little piece of rock which doesn't look like anything
Boring.
special.
Oops, sorry.
Wow, how dare you call any rock
You're
boring,
making Denny
Brian,
angry.
all right? When I flip it over, it's got these really interesting little shapes on them.
Ooh, those look like ferns or something. Is that a
They
fossil?
do kind of look like fossilized plants, but a little bit of a trick. It's not a real fossil.
What?
Actually, these like little black spots are crystal parts of the rock. And so we've got some pictures that we took with a USB microscope that we put on there. And you can see when you go real close to the rock, it's not quite a fossilized fern or plant of any kind.
Just little crystals.
Yep.
So taking a closer look taught us a little bit about that. And Brenna has got a real shiny rock over here. I like shiny.
Yes, so this rock is called labradorite, and it's pretty cool because in certain lighting, it shows off some pretty awesome colors. And I'll see if I can get y'all the colors.
That's not awesome.
There. If I flip it over, let's see if I can get them on the camera.
Oh, saw a flash of something.
Oh, there we go.
Ooh.
Right there. So you can see.
Oh, that's good.
When
That's
the lighting
so pretty.
is at the right angle, you get these awesome colors. But in order to figure that out, you got to take a closer look.
That's right. And you tried a different. Oh, man, that's amazing. That's boring,
old
dull,
rock.
dull. And when you rotate it, I go, oh my gosh, yes.
Look at that.
Yes. That is awesome. That is awesome. Fantastic. So taking a closer look, trying the lights at different angles, that is perfect. And Maud has another, Maud, I got to tell you what you got. It looks like a rock to me.
It
Looks like a rock. I mean,
just some little tan and brown pieces of some stuff. But if you take a closer look at these, you can tell that these are actually petrified wood. And so you can tell a little bit on this one here. If you look along, there's ridges here. And if you follow them in, you can see almost the rings.
Wow. So this is like a piece of a tree.
Yeah, absolutely.
So it was wood and now it's a rock.
And so here on this side, you can see a little bit better on this bigger piece. There are rings around
That's like
here.
The
And it looks,
stem.
yeah, it
Oh my
looks
gosh.
pretty barky there on the side. Pretty tree-like.
So taking a closer look at this rock, you can see that it was once a tree, which is kind of awesome. And Brenna's got a rock, and I have to tell you, Brenna, that rock looks like something I pick up in the morning when I take my dog for a walk. I'm just saying.
Does it look a little suspicious, Brian?
It looks a little,
Here,
does look
Patrick.
a little suspicious.
Looks like some
Yeah, I'll move it
lunchtime
closer to you.
conversation.
Yeah, so this, oh, that's Brian. There we go. All right, so this here, as you can see, looks a little suspicious, and that's because it is suspicious. This is fossilized sloth poop, and it's pretty awesome because it looks like poop.
It does look like poop, yeah.
But if we take a closer look, it looks more like a rock, and actually it is rock. So this poop was in the ground, and then slowly over time got replaced with minerals. And I think we have a picture of this close up, and this poop is called coprolite.
Wow, look at that. But then you can see it's all kinds of crystals.
Yep. So little crystals. So look for poop.
Oh my gosh, you're closer.
Parents are going to be real angry with you.
And Maud has another rock that has some crystals tucked away inside it.
Gave away the cat in the bag.
Oh, sorry.
Could
I'm sorry.
you?
I'm sorry. I
Come on,
stole your
Brian.
thunder. I'm sorry.
It's a rock. It's
It's a
beautiful.
rock. Boring. Rock. Boring.
We drilled a little bit of a hole inside here, and we've got a super cool video that we made with a USB microscope that will show you exactly what's
Whoa, so there we are looking
there.
inside the hole. Whoa, it's got crystals inside it.
Oh yeah. Well, they know that now.
Yeah, Brian, way to give away the surprise.
Oh, sorry. Yeah, I kind of did.
Gosh.
So I can't. It's hard. Don't ever ask me to keep a secret because it's not happening. Oh, that is gorgeous. And there we go. There's a rock and the crystals inside. Awesome. So taking a closer look revealed a little bit more of some awesomeness inside there. And I see there's a direct message here. Luciana and Gianna, can you please announce it's my birthday tomorrow? So Luciana or Gianna,
Happy
maybe
birthday.
both of them have birthdays tomorrow. So happy birthday to you folks. Now, I'm going to show you another rock. And this one here, this is a piece of amber. And then we're going to segue into rocks that do cool things. So this piece of amber, and in Greek, the word for amber is electron. And our words for electronics and electron and electricity all come from amber. And the reason is, if I take this piece of amber and I rub it on a piece of fleece, it builds up a static charge. And I can use that static charge to pick up this feather here. All right. And it could be, we're having little issues with moisture, and we know about moisture and the static electricity. There we go. I'm going to pretend that this goes. And so I have this amber, and it's kind of attracting this feather. I'm gonna dry this out. And the next time I will show this for realsies. But people discovered this. If you take amber and you rub it on cloth, you can charge it up. You get a little bit of a static electric effect. And that's where all of the words for electric, electronics, all that came from this word electron. It's Greek for amber. So that is a rock that does something cool. And Maud has a rock that does something cool.
Absolutely. So here on this piece of paper in front of me, I have got some really flat pieces of mica. And this specific type of mica is commonly called popcorn mica. And we've got a super cool video to show you why we call it popcorn mica.
So you're taking that piece of mica,
We just made sure it was super
heating it up
stable.
with a torch. Whoa!
Whoa.
It's
Mom-
like inflating.
Maud, why does it do that?
So trapped inside all of like the little layers of rock is some like very small droplets of water, and so when you add heat, they expand and they evaporate, and it just pushes the rock apart.
Oh my gosh!
Awesome.
Just like popcorn. Just like popcorn. All right, I'm back. I've dried the piece of amber, and it's still not working. But this is going to work. It worked in rehearsal.
Brian's
We're
a
gonna get there.
liar!
So Maud has a rock that has water in it. Brenna's got a rock that has something else in it. But first, we're gonna do a quick poll, and I forgot to set up the poll for this.
Well-
We're just gonna ask people.
Yep, and you can put it in the chat. So
Put it
I
in
have
the
two
chat.
rocks here. This one is called pumice. And this one is just a rock that I found in my backyard. Do you think this rock, this pumice rock, is going to sink or float? Go ahead and pop your answers in the chat.
Let's see what people say.
Well, I think that that's a dumb question, Brenna, because it's a rock, and obviously it will sink.
All right, Maud. Let's see about
It's a
that.
rock, okay?
I think people are, well, it's about half and half. A lot of people are saying float.
Really? People are saying rocks will float?
I don't know.
I think that's
It's
crazy
a
talk.
rock.
I'm just saying.
Wow. Let's go ahead and try it. So if I put this pumice rock in water, it does indeed
Whoa.
float. If I put this other rock in there, just so you know I'm not a liar,
Oh.
you can see this rock sinks.
But the pumice, that's floating like crazy. And why
Yes.
does it float?
Well, that's because there's lots of air trapped inside this rock. And things with a lot of air in them tend to be more buoyant, and thus they float. It's kind of
So
awesome.
Maud's rock had some water in it, and that turned it into popcorn. And yours has air in it, and that makes it floaty.
Yes.
That is awesome. And Maud's got another rock with stuff hidden inside it.
Yeah, this one's a little bit more, exciting in my opinion. If Brenna wants to make rocks float, I can make them, do other things. And so here I've just got a little piece of oil shale, and it just kind of looks like a plain old gray.
It looks like a rock.
And, well, we've got I decided to take a very safe butane torch in a fume hood to it to see what would happen. And we've got a super cool video showing that.
Okay, so there's our torch.
Propane
Lighten
torch,
it up.
excuse me.
Why would you burn a rock?
Well, why wouldn't you?
It's a good question
Please don't
to
do
ask
this at
here.
home.
Ooh, it's getting all glowy.
Getting all glowy. But wait a minute, that rock is burning.
Oh,
Without the torch on it.
why would it do that?
Well, so it's oil shale, and it smells a little bit, very vaguely, of like petroleum. If you try really, really hard to smell it, I believe, if I'm not incorrect, it has small like deposits of just oil and petroleum in
Nice.
it.
So it's a rock, but inside it is a bunch of oil. So we have rocks with water in them, rocks with air in them, and now rocks with oil in them. This is fantastic. We have a couple more examples of rocks that do things. And before we do that, though, I'm going to do another try of this amber, doggone it. I dried off the amber. I got a feather right here.
You're fired.
It's going. It wants to go. It wants to go. All right, we're gonna come back to that, doggone it. I'm gonna make that thing go. But we've got some rocks that do some cool optics, and Brenna was showing us a rock that had a special optical property, worked like a fiber optic. So we're over to Brenna.
Brian, do you want to talk through the
Oh
things?
yeah, and I'll talk through this. I'll talk through what we're seeing. So it looks like what I'm seeing is there's some cool. She's shining a laser on that, and it only shows up at certain places. Oh yeah, it's like certain zones where the light shows and certain zones where it doesn't show, which is kind of an awesome thing. And so it's staying in that zone, and it's doing that because the rock has got these long fibers in it that go along the thickness of the rock. So it's working like a fiber optic, and the light is following the fibers, which is very cool. And that's a rock called selenite. And then Maud has a rock that does some fiber optic stuff as well. All right, so let's see what Maud has got going on over there. And Maud has got this rock, and I think this one's called ulexite, and this is one of our rocks from Denny. And this has got fiber optics in it too, so there's fibers that go along the axis. There you go, and you can see the fibers. And Maud, go ahead and trace that with your finger so we can see the line of where the fibers go. Maybe turn it sideways.
Oh, yeah.
So we can see the fibers are going up and down. And so the light will follow up and down. If you take this and put this on some words here, you can see the words are brought up to the top, and I see patterns of color. But if it goes straight down at the top, I can see those words. And they're just basically brought to the top of the rock by the fiber optic. And if we go absolutely straight down, we should get a really clean view. Check that out, nice and clear. And that's a fiber optic, such as carries phone conversations and internet, but it's in a rock, which is kind of an awesome, awesome thing. And how is our audio doing? Still no audio. So now, we're gonna go over to Brenna. And Brenna, you're doing rocks that tell a story, right?
I
think
am.
this is your story to tell. So I'm
All
going to
right.
bring my computer over here because my audio is live.
Sounds like a good idea, Brian.
And I'm just going to leave it right here, and it'll pick you
Alrighty.
up.
Cool.
And then you can start talking.
Cool. So yeah, here I have a bunch of rocks, and it turns out that rocks can actually tell us a lot about what has happened on Earth in the past. So here I have something called a lava bomb. And this lava bomb is basically, it came out of a volcano a long time ago as a chunk of hot lava. And then it spun through the air like so. And it flung off little droplets of magma when it did so. And so we get this kind of spinny football shape. So this rock tells us a lot about, where it came from. Tells us that, probably there was a volcano nearby, right? Now I have some other rocks that you've probably seen or have picked up in your backyard. Well, first I'm going to talk about some space rocks, because space rocks are super awesome. And Brian said you could pick up space rocks in your backyard. So here I have a meteorite, or a little bit of one. And this meteorite is made mostly of iron. And meteorites are awesome because they tell us a lot about what happened in the universe a long time ago. So iron meteorite tells us, there must be iron in space somewhere. It doesn't just exist on Earth. Same with this little guy here. It's also a meteorite. And then I have a techite, which is a different type of space rock.
And a tektite, that was like a meteorite hit and made something glassy. Is that right? Is that the way those come?
Yes,
so
I believe so.
It was Earth that was transformed by a space rock.
Yes.
Which is awesome.
Yes.
And Brenna, you got a couple more for us?
I do, unless, Brian, you want to talk about your moon rock?
No, I think we're going to just tell us about your...
Alrighty. So there's some rocks that you can find that tell a story in your own backyard. So in Colorado, we have lots of these red rocks. And red rocks are super awesome because the reason they're red is because iron inside them rusted. So that iron rusted, and the way that iron rusts is it's exposed to oxygen. Now, if you have a super red rock, then that must have meant there was a lot of oxygen in the atmosphere when that rock was formed. So if you find red rocks, they're pretty special because you know that there probably were a lot of plants alive at that time, producing lots of oxygen.
So then you'll be able to...
Now, the last little rocks I would like to show you are some green rocks. And if you see green rocks, most likely you're seeing a mineral called olivine. And olivine is super cool because it's basically the first mineral that forms when rocks form. So if you find a green rock, you know that something huge happened geologically because green rocks are only formed way deep inside the Earth's crust. So if you find a green rock, it's really old. It's kind of awesome.
Awesome.
And
Brenna,
give Brian
thank you
his
for
audio
that.
back.
And Brenna, I'm going to suggest you join the audio on your phone.
All right.
Casey has joined the audio on her computer, so we're each going to do audio through our laptop. Are we going to be deterred by technical difficulties in the Little Shop of Physics?
No, we are not.
I think not. So I'm going to show you a quick demonstration with a fossil. We're into our second piece of rocks that do cool things. And this one right here, this is a dinosaur bone. And I got it, not because it's a fossil, because fossils are cool. I got it because it's radioactive. And I have a Geiger counter here that I can use to detect radioactivity. And when things fossilize, what they do is minerals replace the organic materials in them. And so the bone, the organic materials were replaced by minerals, and in this case, they were replaced by a lot of uranium. And so this dinosaur fossil is actually quite radioactive, which is why I collect it, because I like to collect radioactive rocks. And it turns out this one just happens to be a fossil, which makes it doubly cool. Now, there's other kind of cool rocks that you can get fairly locally, and Casey's got some for us.
I do. So here, Brian, I've just got a big old chunk of a rock called Magnetite. And this rock actually has so much iron in it that it is magnetic.
Oh my gosh.
You
so
can
the
see
magnet
that.
sticks to it, which is cool.
The magnet sticks, yeah. And here's some smaller pieces. The same thing. Magnetic. And you can go around in your backyard. You need a pretty strong magnet for it. But just start poking around in some rocks and see what sticks.
And you've got an example of, like, this is some sand that was collected locally, right?
Yeah, this is sand that's from the Poudre River, so right in our own home. And I've got another pretty strong magnet here. You can see I put it under the paper. It's pulling all of those little magnetic bits.
So you have all kinds of magnetic bits inside that sand. So if kids want to find little bits of magnetite and other magnetic minerals, they can just go into their backyard with a strong magnet and find them?
Exactly.
all I need is a really, really strong magnet. Oh my gosh, that's fantastic. And then Brenna has some rocks that have a connection with electricity, I understand.
That I do, and Adam, can you hear me? Alrighty. So here I have graphite. You might have heard of graphite before because it's in pencils. And graphite is actually, it's weakly conductive. It's not a great conductor, but it does conduct. So you can see I can draw a line here with my rock, okay? And I'll move this closer to Patrick. But I made this line of graphite, and if I place my little circuit here, grab the end of it.
Whoa! It conducts electricity.
I connect the circuit, and if I just, let's see if it, yeah, look at that. Awesome. So graphite is one conducting rock, but there's also others, and galena is one of those. Now galena is super duper heavy. That's what it's known for mostly, but it's very, very conductive as well. So here I have a battery, and it's hooked to the galena, and I have a little LED. And if let me grab my LED well. If I touch the LED to the galena.
Wow, so that rock conducts electricity.
Yes, it does. And it's so conducty that I kept burning out little LEDs on this rock. So kind of awesome.
That is awesome. That is awesome. And now we're over, Casey has got some rocks that do kind of a cool optical thing. And this first thing, that's a little sheet of mica, right, which is very flexible.
Right, yeah, I have this mica here. It's part of this bigger rock that has this crystal structure so that when it breaks apart, it forms these really thin sheets. And you can see, if I place it on this light screen here, it has a polarizer underneath it, a polarizer on top. See if you can see those color changes.
Oh my gosh, look at those bright colors in there.
Yeah, and what's happening is that mica actually, oops, sorry, turned off the light. That mica has different polarization in it, and so when I turn this over it, this other polarizer, it's just allowing certain light to come through.
And I would rotate it until the light doesn't come through. There we go, until it's nice and dark, and then let's hold it there so we get the wonderful colors of that. Oh yeah, wonderful colors in the mica. That is very, very cool. And that's just, you could do that with polarized sunglasses, and we've seen that you can get polarized light from your screen on your phone or your tablet or your computer, which is fantastic.
Yeah.
So that's one way light interacts with rocks. And Brenna's got another one. These rocks, these look like a really boring rocks, Brenna.
Yes,
they look just dull.
They do. They look like really boring rocks, but in fact, they are, and Patrick, it's not on me yet, I don't think. Oh, that's Brian. Here we go.
There it is.
So we got a lot of rocks here. They just look like plain old boring rocks, but if we shine a UV light on them, some of them.
Ooh, that rock turned
Whoa.
green.
Ooh.
Another one turned pink.
Yes. What? They fluoresce. And we don't know why this happens. Some rocks do this, some don't. Some of the same kinds of rocks fluoresce, but others do not.
So if I wanted to like prospect for rocks, I could go out at night with a black light.
Yes.
Matter of fact, I've done that before, which is kind of awesome.
Not surprised.
And you will find rocks that do this. Get yourself a little
will.
portable black light and go do some fluorescent
I
prospecting.
think we have a video of this. I don't know if we're going to show it, but
Here it is.
here we go.
And I think instead of rock light, I would call it light rock. But there it is. Oh yeah, and we've got these minerals. Wow, in the dark room, the colors are much more
Awesome.
apparent.
Wow.
In the short wave, that is dramatic. And then the long wave, still cool. Still cool. But that short wave, man, that was
Yeah, awesome.
the best. Now Casey's got a rock that will do a little chemical reaction, and you've got some hydrochloric acid there, I think, and you can get that at the hardware store, and you could do this with vinegar as well, right? Because that's a nice acid.
Right, exactly.
And right now, we're not having you on video, so let's wait until we get the video up.
Okay.
So I'm not seeing you.
Adam, it says LSOP video.
Sorry, kids.
Oh, that's okay. And then I'm going to suggest what we could do. Can we spotlight Casey's lap? Oh, there it is. Now it's back. Yay! There's
Okay.
Casey. Casey, what do we got?
So I just have a piece of limestone, and then like Brian said, we have some hydrochloric acid. You can get it at Home Depot. And if I bring this right close to you, I'm just going to do one drop, and can you see that fizzing?
Ooh.
Oh my gosh, it's fizzy.
Yeah, this rock just has certain things in it that react with the acid and release that carbon dioxide, and it forms little bubbles. You can actually just take some regular white vinegar, dunk some rocks in it, see if anything happens. They might bubble for you.
Awesome.
Yeah.
That is fantastic. And then one more rock that does something cool. We're over to Brenna.
Yes, so let me turn on my audio. So here I have two pieces of quartz, and quartz are cool because when you squeeze them really hard, way harder than we can squeeze, they release electricity. So you can make a little spark. So we have a video of that. This is called the piezoelectric effect, and it's actually pretty awesome. Let's see if we can, yep, rock sparks.
Awesome.
You
Oh, and so here's two pieces of quartz.
Yeah, so yeah, you see the little light there.
Whoa.
It's just
Wow.
because that rock is squeezing the other rock.
And you could do this with just quartz crystals that you find. I find them on hikes frequently.
Yes, you can find them pretty much anywhere.
So if I'm lost on the hike and it turns into night, I can use a rock to light the way.
You're gonna get an arm workout while you do that.
Yeah, I will get a heck of a workout. And we got 10 more seconds, and in our last 10 seconds, I want to thank Denny Hireman for giving us all the amazing rock samples and being the inspiration behind this episode. Special shout out to Denny. Thank you to all the people who joined us today for Little Shop of Physics Live. Next week, our show is on locomotion, moving through the air and the water and the land. Thank you very much. We'll see you back next week on Little Shop of Physics Live.
Bye, everyone.
Bye. Thank you, Danny.